Hey there! Have you ever thought that your seating position could be affecting your bike's performance more than you realize? We're going to break down the science behind why your seating position matters when you're out on the road. We'll be talking about the different types of resistance, including the ever troublesome air resistance and how it works. Also, I'll show you how your seating position can impact air resistance and why that matters for your ride. Get ready to learn why a good seating position can make all the difference for your motorcycle's performance. First, let's talk about the different types of driving resistances. Air resistance is the force that opposes the motion of objects through the air. Rolling resistance is a force that hinders the movement of objects rolling on a surface. The gradient resistance is a force that acts against the motion of objects on slopes or inclines. And the acceleration resistance is a force that counteracts changes in an object's speed or direction. On the other side, we've got the bike's force. The bike's force impacts the bike's performance. And it's really important that the bike's force is always larger than all the types of driving resistances added together. Otherwise, the bike wouldn't be able to drive at all. First, let's talk about the air resistance formula. F stands for force, or in this case, our air resistance. But we can also say force, since the air resistance is never allowed to be larger than our bike's force. Otherwise, the bike wouldn't move. Cw is the drag coefficient. It is a measure of the resistance an object experiences as it moves through a fluid. A is nothing less than the bike's surface. Here we've got the air density. In this formula it's divided by 2. Air density usually has a value around 1.2 kilograms per cubic meter. Last but not least, we've got V, which is our speed, and our unit here is meters per second. But what's the problem with higher speeds? For finding this out, we will calculate an example. In our example, the rolling resistance will be 100 Newton. The given driving force, which is the bike's force, will be 1000 Newton. The motorcycle's 8 times Cw is 0.55. We will calculate this with 2 different cases. In case number 1, our speed will be 100 kilometers per hour, which is about 28 meters per second. And in the second case, our speed is 200 kilometers per hour, which is about 56 meters per second. Now let's add the numbers to the formula. In the first case, we calculated the air resistance with a speed of 28 meters per second. The result is an air resistance of 258 Newton. In the second case, with the double speed, the result is already an air resistance of more than 1000 Newton. Our bike's force is 1000 Newton, and minus the rolling resistance of 100 Newton, we still got a force left of 900 Newton. So the air resistance is larger than the bike's force. So this speed here is not possible. What can we do to still drive 200 kilometers per hour? We can change our seating position. By tucking in, we could change our Cw times A from the value of 0.55 to 0.35. Now, let's calculate the third case with the new Cw times A. In the third case, we put this value here, and the new air resistance is 658 Newton. With this new air resistance, the speed of 200 kilometers per hour is possible, and our new top speed is 235 kilometers per hour. Thank you for listening. This was my very first video on this channel. I hope that you enjoyed it, and please give me some feedback in the comments. I would appreciate that.